All right, take it away, guys.
Well, hi everybody, welcome. So today we're doing the crash course, very high level overview of data science. And so if you have a minute, please fill out the form with the tiny URL linked on the slide before we get started. And so first we want to kind of talk about some goals we have for the course. So Karen, if you can go to the next slide. Today, the purpose of this crash course is for Eric and I to share a little bit of our personal experience in navigating the field, give y'all a high level overview of data science and what recruiting looks like, what roles you would most likely be recruiting for down the line, and some of the resources available at Duke to help you explore this field.
So at this point, we also want to say that it's not going to be a comprehensive guide to recruitment. Not all the resources that you need would be in these slides. So feel free to use this as a starting off point for you to just try your own journey in data science. So we're going to cover the following things in this presentation. First, we're going to go into the introductions. Then we're going to look into the field in general. And then we're going to look at the recruiting process, cover why you should be recruiting, what things you should be looking out for when you're recruiting, what kinds of questions you're going to get. And then we would cover the kinds of things that you might want to look into to build experience so that you can answer those questions. And then we end off with a quick Q&A.
Great. So before going to introduction, I just want to say if you guys have any questions, feel free to unmute yourselves, interrupt us, ask along the way, or you can put it in the chat box either to everybody or privately to me and Eric. We'll be looking out for those and answering your questions along the way. So yeah, so with that, I'll go ahead and introduce myself. So my name is Daisy. I am a senior, double majoring in statistics and psychology, and I have a concentration in data science. For the past few summers, I've been a data analyst intern at White Closet, which is a fashion e-commerce startup. And the next summer, I was a data science intern at Lineage Logistics. My project focused working on labor optimization. How do we make that more efficient and save money for the company? And for this past summer, I was a summer associate at the Boston Consulting Group working on corporate strategy at a growth tech company.
My name is Eric. I'm a junior majoring in statistics and computer science with a minor in math. Last year, I started looking into machine learning and got very interested in that and used that for a few projects, one of which include the Datathon. And I've had a data science internship with Shopee, which is an e-commerce company, where I looked into detecting client fraud with natural language processing. And then I did a software engineering internship with Palantir. So with that, let's start with a brief overview of the field.
So first we want to ask the question of what is data science anyway? For the past few years, data science has obviously become such a buzzword. You hear data science, machine learning, data analytics, big data thrown away, like just thrown out there all the time. And a lot of the times, at least for me, when I think about data science, I immediately think about the visualization, conducting hypothesis testing, running some regression models, and or even using some machine learning algorithms to answer questions. But if there's one thing that you're going to take away from today's session is that we want to know these are only the tools that data scientists use to solve problems, but these tools do not define the role of a data scientist. So a data scientist would use data to solve business problems and create impact, and that's at the core of how this role fit in at a large or small company for that matter. So in the next slide, we have found a video called What Really is Data Science by Joma Tech. So he used to be a data scientist at Facebook, and we found this to be a really great intro video to the field. And one of the quotes that we really loved is, being a good data scientist isn't about how advanced your models are, but how much impact you can have with your work. So I don't know if you guys have taken any stats courses, but one word that you'll hear a lot is the word parsimonious when it comes to modeling. So basically it means that you want to use the simplest model to answer the question. If it doesn't have to be complicated, then don't make it complicated. With data science, obviously, it's really easy to go crazy with complicated machine learning models, but you also sacrifice a lot of the interpretability that comes with that. So this is kind of a theme that you'll see across the field, no matter which role you want to go into. So next, we want to give you guys more of a visual kind of overview of the field of data science. It's incredibly interdisciplinary. So the way that I think about it is that it really sits at the intersection of three main domains. And those are computer science, math, statistics, and business and domain expertise. So what it means is that there's also a lot of opportunities within data science where you can be on a broad spectrum in terms of technicality. So we'll go into that a little bit later. But just to give you a preview, for example, for me personally, I am more interested in the intersection of statistics and business because I think it's really exciting to be able to use data to answer questions, but ultimately that data is taken into insights to motivate business decision making. And Eric will talk about it a little bit further down the line, but he is more interested in the technical side of things and more at the intersection of math, statistics, and computer science. So his interest is mainly in machine learning. But regardless where on the spectrum you fall, some of the we wanted to kind of just show you guys some of the typical questions that a data scientist will be asked to answer in the field. And so some of these questions can be, how do we customize ads for different demographics of customers? And this is super common for any essentially social media platforms that we're familiar with. When you're thinking about, like, I was just talking about pizza with my friend, like, why is it showing up in my Instagram feed? So that is something that a data scientist can work on. And the second question, obviously, Uber and Lyft has been driving this field a lot of, like, what is the most efficient way to match a driver and riders? And this can easily become very complicated with a lot of network analysis, etc. And lastly, some of the classic prediction problems of how do you predict customer volume in a store so that you can schedule shifts for your sales crew. So for example, you can probably easily think of like machine learning's application in this sense, but these are some of the questions that a data scientist would be asked to answer. And as you can see, it's very broad, and you would be responsible from getting the raw data to cleaning things to really producing insights to help answering these questions. And some of the languages that are most commonly used, at least for the data analyst and data science roles, are SQL, obviously using to query raw data from databases, R, and Python, and we've listed some of the commonly used packages here.
And so now I'll be covering all the roles that you would most likely be applying to if you were looking at a job in this field. So I think it's the easiest to cover these roles first looking at the data pipeline. So at the top of the pipeline, we have the data engineer. And what the data engineer usually does is that they're responsible for taking all the different sources of data, putting it into one place and pipelining it, eventually giving it off to either a data analyst or a data scientist. So the difference between these two roles are kind of fluid. The data analyst sits somewhere closer to a non-technical part of the pipeline. So the data analyst would be taking this data, cleaning it, analyzing it, and just visualizing it. So imagine just like showing different views of the same kind of data, but in many situations, this might already be enough to answer the questions that you might be wanting to answer. The next thing that might be required if the data analysts or certain visualizations don't give you the results that you need is to bring in the data scientist. And the data scientist would be involved in more of a technical role in building more predictive models. These might include machine learning models, conducting A/B tests, and then discovering all those hidden patterns that may not be uncovered with simple visualizations. So in undergraduate recruiting, you would most likely be applying to the roles of a data analyst or the roles of a data scientist. Now, there are other roles that you might be seeing when you apply for data science jobs, and these are the roles of the machine learning engineer or the machine learning researcher. Most of the times, these roles are only applicable for people who have a graduate degree, but some companies do hire undergrads for these positions, so we'll just cover them very briefly. So machine learning engineer is looking at implementing different machine learning algorithms that come from the researcher, or maybe a data scientist who thinks about an algorithm would pass it off to the machine learning engineer. And then the machine learning engineer would take this model and integrate it to the current platform. So I think it's important to also understand that there's this term called the machine learning lifecycle. So a lot of times we're thinking in terms of the starting part of a life cycle, where we think of what's the algorithm behind the model, what are the assumptions that we place on this model, and how do we feed in data into this model, and what's the output. But the thing that we don't really cover in a lot of classes is that there's a second part to this life cycle, which is let's deploy this model, let's put it in the platform, let's monitor it, find out what metrics we want to use to make sure that the quality is still there, and then maybe come back and tweak the model again. So that integration would be what the machine learning engineer would be looking out for. And the researcher would be looking at new kinds of methods or reading the cutting edge papers to find out if there are new recommendations that they might want to give to the data scientist. And
So next, oh, go for
sorry.
Eric.
And having said all of this, we know that although the roles might be very well defined, the actuality of the situation is that data roles are very confusing and fluid. So when applying, here are some elements that you might want to consider.
Yeah, and the first one you want to think about is the level of technicality of how involved you want to be with coding. So this is when I'm super glad to have Eric here with me, because we're pretty much at the two ends of the spectrum, where I am more interested in the business side of how we can use data to provide insight and tell a story so that eventually we can make a business decision, whereas Eric is a lot more interested in the highly technical side of machine learning. So there are a lot of roles out there that suits varying levels of technicality depending on what you feel most comfortable with or are most excited about. So this is something that, I would argue kind of the first thing that you should consider when looking at data science roles at different companies. And the second thing we want to talk about is industry. So data science, as we talked about, is very fluid, and it is an incredibly interdisciplinary field. And what that means is that you can do data science pretty much for any industry. There's data everywhere, and you can do data science at a tech company where, for example, you can answer questions of how to recommend posts to Pinterest users, and that's kind of the most typical one that you probably normally think of, and the most typical roles that recruit at Duke. And the second one is that you can also do data science in consulting firms, where data scientists will typically work in parallel with a general consulting team, and they would use their expertise to build more complex models or even data products for the consulting team to then be passed on to the client. And the third general places is just all other industries. So for example, Eric and I have both done data analyst, data science roles in e-commerce. And so you can really be at any company and helping them to leverage their data to be able to bring value.
Something else you might want to consider is also the company size. And so this is a broad generalization, but when you're working for a small company, the likelihood is that if you're recruited for a data science role, or you are a data scientist, you become the person that everyone turns to for a data problem. So that would mean that you would be tangentially or even very involved in the data engineering process or anything along that entire pipeline. So if that's not your cup of tea, you might want to look into recruiting for a larger company like, say, Facebook, where the roles are a lot more siloed, and then you can do the job that, say, you are most interested in or you were hired for. Having said that, these are all generalizations, and therefore we would recommend that the most important things to do is to just read the job description when you're applying for jobs, talking to the people who are involved in the recruiting process, talk to data employees at the company, and just reading online reviews about what your job most likely entails. And so without further ado, let's get down to recruiting. So firstly, what is recruiting and why should I recruit? And recruiting is a process where we get an internship or maybe a full-time job. So it's important to realize that in Duke, everything is very pre-professionally oriented. And it's very important to know that recruiting is just a process between you and the company. So don't think too much about what everyone else is doing. Reply when you're ready, but preferably a little early. And just make sure that you're doing it for the right reasons and you want to get a job at said company. And so what are the right reasons? I personally feel that recruiting is important because one, you get experience in dealing with data. You learn all the different techniques with regard to dealing with data in the real world and bring that all the way to insight. But more importantly, you find out whether this is the industry that you like and what you want to, what things you want to prioritize in, say, your next internship or your full-time job.
So next we'll really briefly go over the recruitment timeline and the process. So this is fairly similar to a suite internship where you can see on the right, it starts with a resume drop, a few rounds of remote interviews, and then hopefully you'll get your offer. And in terms of timeline, typically recruiting will start in late August, but it can also go until April, very dependent on the role. So for example, for data science, some of the bigger companies may have a more defined timeline where they would recruit mostly in the fall, but plenty of roles are still going to be available in the spring. So there's no rush to kind of compare yourself with other people who may have gotten jobs earlier than later. There's going to be a lot of opportunities open until the springtime. And next, so if you do decide to recruit for data science, we want to briefly cover some of the questions that you may expect. So first, it's very typical that you will get a coding challenge that is fairly similar to the HackerRank problems that you will get for a software engineering role, except you probably most likely won't be coding in Java, answering data structure type questions. It will be in SQL about manipulating data. And most of the time, if you submit your resume and pass the coding challenge, you would get a recruiter phone screen where the recruiter will briefly ask about your past experiences and projects working with data, and some very simple kind of just screening questions to see if you're familiar with different coding languages. And next, one thing this is, the take-home analysis is very unique to data science. This is when you essentially tackle a datathon type problem where the company will likely give you a data set and then a few guiding questions for you to conduct analysis, write up your basically answers and then turn it into a presentation. So you can either choose to do that in Python notebook or in a markdown file and then package it up to send back to your recruiter. And lastly, before you get an offer, it's very common that you will have a live interview, and that could either be virtual or an on-site interview.
So I'll briefly cover the kinds of coding questions, or not coding questions, the kinds of questions that you'd be getting in recruiting. The first kind of question would be a coding question. And most of the time, the company would allow you to use the language of your choice, but you should also be aware of, say, SQL HackerRanks. So a data wrangling question could be, say, they give you 3 or 4 data frames and they ask you to find the employee that was paid the most. A regression question would be to give you a data set and ask you to fit a regression model on it. So those are some very basic questions that could appear in either a coding challenge or any kind of live setting. There are also theory questions that may come out in the form of a quiz that you take like asynchronously or in an interview. So there are regression questions that I've seen, such as explain to me what Cook's distance is, or hypothesis testing, which is define a p-value. There's also something that they like to ask a lot, which is called A/B testing. And how A/B testing works is, say you're a web company and what you do is to give people or different subsets of people 2 different variants of your website to look at, and then compare the conversion rates, which is the rate that people click on the ads. And so the questions to ask would be, how do you design this? How do you sample this? at what percentage is my result statistically significant, and how do I go about interpreting my results. And the last thing could be about machine learning algorithms. So one question that I've seen was, explain to me why random forests use a bunch of trees, for example.
And it's also totally fine if you guys don't know the answer to any of these questions, because you will learn them in your stats classes, or it's not very difficult to prep. And we'll include additional resources at the end of the presentation. So I want to talk about the last type of questions that you will likely get, which is product or business questions. So it's also very common for in an interview for you to be asked to talk about different metrics and KPIs that you would use to evaluate the performance of a product or the company. Again, as I said, data science roles can vary different, like a lot across companies and which kind of part of the pipeline you're on. But if you are interviewing for more data analyst roles close to the product, then you'll definitely expect these questions. That's a little bit more qualitative and quantitative, kind of a mix of the both of the two. And some companies would even do a case interview, but that's will be less common.
Yeah. So now we want to go into the things that you can be looking into to build the experience to answer those questions that you saw on the previous slide. So here are a list of opportunities that you can use to build this experience. The first thing that's great to get into would be clubs. The first one there would be Duke Undergraduate Machine Learning, which is great for speaker series and workshops. Duke Applied Machine Learning provides training first and then links you up with projects, which is great to get your hands dirty with people and with actual projects and actual data. I also found it very useful to be part of the stats majors and minors listserv, where Joan sends out a bunch of emails all the time with regard to opportunities, data thons, and things like that. And for women who are interested in data science, DTech, WIT, and BO are all great resources to look into. Some programs you might want to look into, which are all summer programs, I believe, would be Data Science Phoenix Project and Plus Data Science. Plus Data Science would be going around through the year also. And I think the same holds in that it's great to just get more experience with dealing with data, because that just gives you more things to talk about in your recruiting cycle. With regard to classes, we will give a list of classes in the next few slides, but I want to cover Udemy and Coursera. Coursera has Andrew Ng's class on machine learning and like a lot of different forms of machine learning. So those are things that you definitely want to look into. I think research is something that people might want to look into also if you're more interested in a technical role. Research, if you manage to get published, would be a great thing to talk about in your recruiting interview and would also give you a lot of experience. But I also want to stress that you should not be doing research just because you want to get a job, but because you want to be interested in the fields. And just to list off a few professors, Lawrence Karen does a bunch of research with regard to data, machine learning, and health. If you want to look into causal or inference, you should do some research with Cynthia Rudin. If you want to do computer vision, Tomasi is a great resource. And so the point that I'm trying to make would be find out the area that you're most interested in, and then find out which professors and what kind of research they're doing in that area before reaching out to them and then developing an interest in that area. I think datathons are also great because it forces you to learn a lot of things in a very short period of time. And at the end of the day, most of the time you have to give a presentation, which means that you get this entire process of taking data, cleaning it, doing EDA, putting on a model, and finally delivering insights. And it's very often that you get lost in the weeds and you don't realize that insight is the most important thing. And then the last thing that a lot of people do to get a bunch of experience would be side projects or Kaggle competitions. And Kaggle is a great resource because you have a bunch of data sets that you can spend time cleaning and getting insights out of. And Kaggle also has notebooks, so you get to see what other people are doing and how they clean the data and the different like analyses that they do on data sets.
Great. So when I talk about core classes, Eric, do you want to drop the name of the professors and research areas that you just talked about in the chat? So here are some core classes for the stats major, but we wanted to really highlight these. This is not comprehensive, but the ones that we think are most relevant to data science. So if you haven't taken an intro to stats course yet, we highly recommend taking stat 199, which is an intro to data science, instead of stat 101 or 102. So this class will get you really comfortable with R, working in a team and just doing some basic data analysis projects that is beyond the just basic statistical knowledge that you would probably talk about in like AP statistics, for example. And stats 210 and 240 are also two classes more on the applied side that will be helpful to kind of build a foundation if you're interested in data science.
Yeah. And here are some elective classes that are outside the statistics core. These are the courses that would be useful for general knowledge. For example, if you want to learn SQL, 316 is there. And but at this point, I also want to note that there are a lot of graduate courses here, and it's not necessary that you do have to take graduate courses to get a data science job. As you mentioned, there is a spectrum of technicality with regard to what kinds of jobs you want. So if you do want to aim for something that's very technical, it would make sense to take a lot of these more technical focus classes, but there are also a lot of other classes that pertain to the business side of data science. And then these are classes that you might want to take to further explore a topic area. Again, these are mostly graduate courses because they're very specialized. But say if you are interested in computer vision or self-driving cars, then maybe taking 527 is a great option. Again, I want to stress that don't take the classes just because you want to get a job, but basically take it if you're interested in the topic area. And so to end off, here we have some basic resources. When you get the slides, these are all links that you can use to just get started. I think this is a great resource that would cover both code, practice, and just introductions into the things that we've talked about in this course. And you can just use this to get started on your data science journey.
And before we move on, I just want to emphasize that it's totally okay if you don't want to take a lot of grad classes. That those are definitely not necessary if you are interested in data science or want a career in data science. So for example, I have taken almost no graduate classes, but Eric has taken almost no undergrad classes. So this is, again, just to show that there are, it's a very wide spectrum of technicality that we talked about before, and regardless kind of where your interest lies, you will be able to find roles that kind of fit with your goals.
And so at this point, we also wanted to give some acknowledgements to G, who had just graduated last year. I talked to her and got a lot of the resources that we talked about from her. And yeah, with that, we are done with our presentation. Thank you.